Now here's a very important question whose answer you should always remember. Why does H2O2 act as a reducing agent as well as an oxidizing agent? So for this, let us first draw the structural diagram for H2O2, which is like this. Now oxygen is more electronegative than hydrogen, therefore there is a delta negative on this oxygen and delta positive on this hydrogen. That is, the electron pair being shared over here is being shifted a bit towards oxygen side, and the same is the case here. There is a small delta positive here and a delta negative here. There is no transfer of electrons between these two oxygen atoms. Therefore, the oxidation number of oxygen over here is -1. Both the oxygens are in an oxidation state of -1. Now we know that the oxidation state of oxygen can be -2 or it can be 0. -2 in the case of H2O and 0 in the case of O2. Therefore, H2O2 can act as both a reducing agent and an oxidizing agent. When H2O2 acts as an oxidizing agent, then it itself gets reduced. That is, the oxygen gets reduced to H2O. When this acts as an reducing agent, then it itself gets oxidized. That is, the oxygen atoms get oxidized to 0 state and O2 is formed. We will see the equations for the two cases. Now when H2O2 acts as a reducing agent, H2O2 gets converted to O2. Here the oxidation state of oxygen is 0 and the oxidation state of oxygen over here is -1. So there is an oxidation. We balance this by 2H plus 2 electrons. Therefore, we can also say that as electrons are being released, therefore this H2O2 is being oxidized and it acts as a reducing agent in the procedure. Now for considering the case of oxidizing agent, H2O2 gets reduced so that it can act as an oxidizing agent. The equation thus becomes H2O2 plus 2H plus 2 electron becomes 2H2O. We can also see that H2O2 is accepting electrons so that it gets reduced to 2H2O and therefore it acts as a oxidizing agent because it itself gets reduced. We can see the oxidation state of oxygen over here is -1 and the oxidation state of oxygen over here is -2. So we can see that this is reduction. Therefore, in the process of itself being reduced, it acts as a oxidizing agent because it accepts electron from the other substance. Over here, the H2O2 is getting oxidized. Therefore, it releases the electrons for the other substance to be reduced. Therefore, H2O2 acts as a reducing agent in this case. This equation can also be written as H2O2 plus 2 electrons gives us 2OH minus. Now, therefore, you should also always remember these two equations of the reducing nature and the oxidizing nature of H2O2, and we thus prove that and explain why H2O2 acts as both reducing agent and an oxidizing agent.